as we take a look at finding each of these inverses, remember our first step is always the same and always, I hope at least, very, very easy to do. The first step of finding any inverse is to swap x and y. And that's all you're doing. And so for number 1 then, the very first thing I'm going to do is write this as x equals parentheses y plus 4 squared. Nothing else is changing about it at that time. All I did was swap the position of each letter. From there, there's only 2 steps. The second step is solve the equation for y. It's just that second step sometimes is a bit involved. In this case, we're going to go ahead and start solving from there. So I need to get rid of the squared because that's the outermost thing going on in our equation right now. What undoes the squared? Square root, absolutely. And so we take the square root of both sides. But if you write it exactly like this, there's something slightly off there, right? What do we need to remember to include? Plus or minus. Whenever you take the square root of both sides of an equation, you must remember that plus or minus. All right, and finally, we're still trying to get y equals, so y by itself. So the last thing is I subtract the 4 from both sides. And so we end up with plus or minus root x minus 4 equals y. And now that I have y equals, I'm done. That's it. All you got to do, that's our inverse equation. All right, number 2, same basic idea. We start by swapping x and y. So x equals y minus 2. We then solve it for y. Nice and easy on this one though, right? In this one, you should get a final answer of y equals x plus 2, because all we got to do is add 2 to both sides of that equation. All right, finally, for number 3, well, first step, of course, is the same. First step is something we're all very familiar with. We've done it lots of times. We switch x and y. So we got x equals 1 over y minus 3, and now we're solving it. And for some of you, it's easy to solve. For some of you, this is a challenge to solve because it looks kind of weird. And so, if this one is a challenge to you, I would say the easiest way for most people to look at this, the way that where it all of a sudden is like, oh, that's not as hard, is if I actually write it as a proportion. Because since I have a fraction over there, I can write it as x over 1 equals 1 over y minus 3. And then I can cross multiply to solve from there. So we end up with x times y minus 3 equals 1. All right, now this does look kind of scary at the moment, but I'm still trying to get y by itself. So go ahead and now divide both sides by the x. Now that makes things a lot cleaner because now we have y minus 3 equals 1 over x. Let's move that up so we got a little bit more room. And then last thing is then we would move the 3 over so we'd have the y by itself. So we're going to have y equals 1 over x plus 3, and that's it. That's a final answer. We're done with that one. That's our inverse. So to continue practicing our inverses, please find the inverse of this equation now. And I'm hoping that you're automatically thinking swap x and y first. Now, if you have trouble looking at it with the f of x in there for swapping the x and y, start by writing it as y equals instead of f of x equals. It does mean the same thing. It's just a different notation. And then you could swap x and y a little bit more easily. But again, you only have to write that step if it's a little bit challenging to go straight from here to here. Because this last line that's currently up there is the big one that we are going for. Now that we've swapped them, now we're solving it for y. So as we're working this through, we want to start by moving that 6 over. Then we divide both sides by 2. And now we got y squared equals. So now I want to get rid of that squared. So I take the square root of both sides. When we do that, we end up with a y equals square root of this big old fraction, x plus 6 over 2. And of course, when we take the square root of both sides, what do we need to remember to include? Yep, the plus or minus. Always want to remember about that part. And maybe last little step, remember we started with f of x equals, so I'm going to go ahead and write my final answer as the inverse of f of x. I'm going to go ahead and use that inverse notation, but this is just a notation change we aren't doing anything different to our equation. Now technically this is our inverse equation. If I asked you to graph that, would you be able to?
No.
Probably not. We don't know, we haven't talked about at least what dividing by 2 inside of the square root would do. It's different from what it would do if the 2 was outside. And so I could still, though, in the coming days, ask you to graph it. So how would you? Well, you would start by graphing your original equation, 2x squared minus 6, because we do know how to graph that one. It's down 6 and then vertically stretched by 2. And so then we could graph that one and then go point by point to make our inverse graph. So remember, you always have that as an option. And sometimes we have to use that option, like in this kind of a scenario. Continuing our practice, looking at some different function types now. Find the inverse of each of these equations. It should go fairly quickly on each of these, please. All right, so for solving each of these, the first one, step 1, swap x and y, so we end up with x equals 2y. Last step, figure out what y would equal. And so in this case, we divide both sides by 2. Y would equal x divided by 2, which you also could have written as 1/2 times x. That would mean the same thing, of course. All right, the second one, we swap x and y at the start. So we go x equals y squared. Because remember, of course, f of x is the same as y. I then square root both sides. And so we end up with plus or minus square root x. Little detail-y thing. Since I started with f of x, I'm going to go ahead and write my answer as inverse of f of x. But of course, that's just a notation thing. And then the last one. We have y equals the square root of x. Well, swap x and y, so x equals square root of y. To get rid of the square root, we square both sides, and so y equals x squared. Now, there is a caveat to that, kind of like with what we were seeing on last night's homework. We're going to be coming back to this equation and see that this is not actually entirely correct, but our algebra is right here. We're just going to add one detail down the road as we get further into these and after we're a little bit more comfortable with them. But we'll save that until after we've practiced them more. Now, we just went through a number of different function types. There's 2 other function types here that I want to take a look at. So please find the inverse of each of these. So for that first one, g of x equals x to the 5th. We start by swapping x and y, right? So we end up with x equals y to the 5th, but then we have to undo the 5th power. What undoes the 5th power? Well, remember, what undoes a second power? Like undoes squaring? Square root. What undoes a 5th power? Fifth root. Exactly. So I take the 5th root of both sides. So we end up with just y equals the 5th root of x. Now, we get be a little detail-y here. Do we need to include the plus or minus out front of this? The answer here is no. But this is just being a little detail-y here. Why do we not need to? Because the exponent is odd. A negative number to an odd exponent will always give us an odd. It's not like the even one where it turns a negative into positive. So this is new, but if we take an odd root of both sides, you don't have to worry about the plus or minus. It's only for even roots. All right, last little detail on that one. Again, I started with g of x, so I'd go ahead and write my answer then back in the function notation, writing as inverse of g of x. All right, but now on this next one. First step, nice and easy, swap x and y. We start every single one of them the same way. So x equals 5 to the power of y, and then we need to solve it for y. But this is where things get interesting. Like in the last one, if it was y to the 5th, we took the 5th root of both sides. If we try to do that here, it'd be like the y root. We can't really do the y root of x. It's not a thing. At least not anything that's going to be useful to us. So we don't want to go there. We need some other way to figure out 5 to the power of what would equal x. We need a way to solve for an exponent, but we can't use a radical. We need some other function type. And in fact, there is another function type which exists solely for this purpose in math, something that you've seen a lot on your calculator, but have probably never known quite what it does. It's log. That's short for logarithm. Please add this into your notes to see how we can use it, and then we'll talk through it and see how this actually helps us solve that last one. Now when you see log here, log is just short for logarithm. A logarithm basically is a type of mathematical function that specifically allows you to solve for an exponent. And so you'll notice that's the way this thing gets constructed. Now when you wrote this into your notes, let's make sure you wrote it right, a little detail here. Notice that we have this b here. It is written smaller and lower. We call that a subscript. It's kind of like an exponent, but instead of being written higher, it's written lower. This y is normal size. It's not smaller, it's not higher, it's not lower. This is written the same as we wrote the log. Same thing for the x there. So, notice that I can change anything from exponential form like this, and I can rewrite it like this. Basically what we're saying here is that this is the exact same thing as this. Now when I read this over here, notice it's log little b y. We don't want to go through life though reading log little b y. So that little b there, it's actually called the base of our logarithm. Just like this b is called the base of the exponential. So when we read it as log base b of y. Now I can now take this and use it to solve this problem that we started earlier. Now that I have x equals 5 to the power of y, I can now solve this for y by writing it as a logarithm. So it goes y equals log. First thing I write after log is the base. The base that goes down here is the same as the base of my exponential. It's whatever's raised to the power. So those two numbers have to be the same. We called that b in our notes. And so it's going to be log, and then we write a subscript 5. In other words, smaller and lower. Then, what is it log base 5 of? It's always log base 5 of whatever the exponential is equal to. And so it's going to be of x. And then we have our equation. We have an equation that has now been solved for y by using this little trick with something called a logarithm. Now we're going to be getting into, okay, how can we get actual numbers out of the logarithm? But for the moment, just know that logarithm is actually a button on your calculator that will actually do some of this function for you as well. All right, so notice what log tells us. Log equaled y. Y was my exponent. This is why we have logarithm. It's such a critical idea. I want you to add this with your notes as well, that logarithms exist for the purpose of solving for exponents. Now I mentioned that logarithms, you would have seen a reference to it before because you would have seen that log button on your calculator for all these years and been wondering how can we log something in math. What on earth could that mean? Now we're going to start seeing how we can use that and actually figure out some values. But we aren't going to use the button on your calculator yet. There's some complexities with that, and we want to make sure that we really understand what it's meaning before we start doing the calculator work. So we're going to instead with just some easy problems that we can do without a calculator. So we're going to actually figure out what these three all equal. Take a moment, write the three problems down on your paper so then you can write the work as we do it. All right, so for that first one, as I look at it right now, there is a way to look at it and know what the answer is without having to change the form. But I want us to get used to changing the form, so I'm going to go and use those notes we wrote down. I'm going to start by rewriting this equation into exponential form. So the first thing I write in my exponential form is b. Okay, so I go over to my notes here and I see, okay, b is that number. It's the base. So I go over to my equation over here and I see what is the value of b. You can see it's a 9. So the first thing I'm going to do is write down 9. Next thing in my notes is I see it's to the power of x. So I got to figure out what that's going to be. So I can see that in my equation here from my notes, x is the one that's on its own. Log always equals the exponent. That's the way I remember it. And so what I'm doing is I'm looking over here to see what is on its own by itself in my equation. Well, conveniently enough, it's still called x. Of course, that won't always be the case, but it is whatever it equals. So this is going to be 9 to the power of x equals, now you can probably figure out what the other is by process of elimination, but let's see how we use our notes to be sure. It's going to be equal to whatever y is. Now notice y is represented in our logarithm function as this number. It's the number that we're finding the logarithm of. That's the big number in the logarithm. That's the 81 in this particular case. So it's going to be equal to 81. Now, normally we're using logarithms to try to solve something like this rather than create it where we have the x and the exponent. But I'm doing it here because I actually know what this is off the top of my head. 9 to the power of what equals 81? Now sometimes the temptation with this is to say it's 9 because we're thinking 9 times 9, but of course if 9 times 9 equals 81, that's actually 9 to the second power. So we found out that x equals 2. And then that's how we can do this whole process, is we can just rewrite each of these as an exponential and then figure out what it is. So let's go through the next two really quickly here. I'm going to start by rewriting that as an exponential. That becomes 5 to the power of x equals 25. I do that because I do know 5 to the power of what equals 25. What is it? 2. So x equals 2 again. All right, next one. This one is 4 to the power of something equals 64. Notice, I can basically read my logarithm like that. Log base 4 of 64 means 4 to the power of what equals 64. And this is actually one that we also should know that we've seen before. It's not a 2 this time because 4 squared is 16. But 4 cubed, that is 64. 4 times 4 is 16, times 4 is 64. So x equals 3 there. In other words, I would look at the original and I'd say 4 to the power of what is 64? It's 3. Right, now I would like you to practice this idea. Please evaluate each of these three expressions. Figure out what x equals in each. All right, so for that first one, when I see log base 7 of 49, what I'm thinking is 7 to the power of what equals 49. And that's what I'm thinking in my head, but I can also write it down to see it visually. And so the answer here is 2, because 7 squared is 49. Next one. In this case, it's 3 to the power of what is 81? Well, 3 to the power of what would equal 81? It's 4. Because 3 times 3 is 9, times 3 is 27, times another 3, that's a total of 4 3s, is 81. And then finally, this last one is basically saying 5 to the power of what equals 125? Well, that's 5 cubed is 125. So the answer then is 3. All right, last thing, I just want to practice and really ingrain this idea about how we switch between exponential and logarithmic forms. So, please write each of these as a logarithm, and then please write each of these as an exponential. All you got to do is just follow the pattern from your notes on these. To check that you're on the right track, for that first one, you should get log base 5 of 10 equals x. No, we cannot figure out what x equals in this case. It'd be a funky decimal, because 5 to the power of no whole number would equal 10. As you're writing these, the way that I memorize it, because of course you'll have to have this down eventually, I always memorize that log equals the exponent. That's a little trick for remembering how to reorganize these. And then there's all of our answers. And again, remembering that log is always equal to the exponent helps immensely with just knowing where to put each of these little pieces.